testing, and we're going to be diving into different techniques that allows us achieve this kind of testing, or that allows us achieve precision testing basically. And some of them are equivalent partition, boundary value analysis, and decision table, right? And all of these are all um, types of software test case design techniques, right? They are all test case design techniques. And what is test case design technique? Uh, they are basically it's like an approach that we employ in testing to help us um, achieve high coverage, like high percentage of test coverage with um, minimal number of test cases, or with minimal effort, basically, right? So today what the first slide here says objective, right? And there's a question mark. And what do I mean by this? So what is the objective of this session, or what is the objective of what we're going to be talking about today? So the first thing is, the essence of this conversation is for you to have an understanding of these concepts, have an understanding of what equivalent partitioning is, how to apply it in testing, what boundary value analysis is, what decision table is, and how to actually apply it in your day-to-day testing as a software tester, or as an aspiring software tester, right? The next thing is for you to learn how to apply it. Okay, I already mentioned it, in your software testing career as a software tester. Um, why are these techniques important, or why are these techniques that we're going to be talking about important? So first of all, they help us to ensure comprehensive test coverage, right, with minimal effort. They help you optimize your testing efforts and minimize redundant tests. And when I say redundant tests, I mean a situation where, I don't know if you've like, I've had the opportunity of looking at some people's tests, test documents, like people that I mentor, and then you see that they've written test cases, and you can see like a number of test cases that should actually be one. Do you understand? You just like one test case would actually cover for these things that they have written, right? So applying some of these techniques will go a long way um, to help you reduce redundancy when it comes to test cases, right? Yeah, so let's dive in. The first one we're going to be talking about today is equivalent partitioning. And so what is equivalent partitioning? Basically, we've been saying equivalent partitioning, equivalent partitioning. So what is it, right? So equivalent partitioning is a black box test technique, right? That focuses on dividing your input data into different partitions, right? Or maybe classes. Now, each of these class or each of these partition, you pick one data to represent them, like to represent a particular partition. So let's say, for instance, you divide your input data into, say, partition A, B, C, right? So from partition A, you pick up one data to represent everything, irrespective of the number of values that fall into that partition. You just pick one to represent them. And whatever value, or whatever result or output that particular data or value you have picked gives you is what you use to judge every other thing in that particular partition, right? Or you just use it to actually judge whatever values fall into that partition. Now, the essence of this test technique is to reduce the number of test cases, right, while ensuring effective test coverage, while ensuring that you have a maximum level of test coverage with the barest minimum of test cases, right? Now, how do you achieve this, or what steps do you take to achieve what you want to achieve using equivalent partitioning? So I've lifted out 4 points, and the first thing here is identifying your input conditions. So you need to look at your scenario, or look at your problem, or look at what you're trying to test, and then identify the input conditions for this particular scenario, or app, or whatever it is that you want to test, right? Now, the second step is for you to divide your input data or input conditions into equivalent partitions, right? The next step is you then select a representative, right? It's just like saying, we have like maybe classes. Maybe you have, let me use, our primary school as example. You have primary 1 to 6, right? It's just like those days when they you say, oh, we are going for a competition, please bring out one representative to represent your class or represent something, right? And then each of the class, maybe from primary 1 to 6, will bring out one representative. So if that person fails, you just know that your class has failed. If the person passed, you just know that your class has passed, right? So I'm just trying to like give like a real life ideology to what I'm trying to explain. Now, the next point is you then create your test cases for each of the selected value, right? So enough of the English. Let's see this equivalent partition in practice, right? Or in action. Let's see how it works or how to go about it. So here I have a scenario of a program that validates numeric fields. Now, this program could be anything. It could be a function. It could be you know what, let me just use a real life example that we might have come across or not. Right. So let's say, for instance, this numeric field, this program or this field that takes in numeric values is, say, a field. Maybe you're filling a form and then there's a field for age, right? Age. Let's say the field requires you to, put in your age and then whatever, but the form includes that particular field. Now, and you as a tester, you want to test that field, right? So, let me stop there. Now, there's a condition attached for that field, or let's say requirement, basically. So there's requirement for this field, right? And then the requirements are, first, the values less than 10 are rejected. So let's say you have age 1 to 10, or maybe, in fact, as long as you're not up to 10 years, you are not accepted to fill that form, right? Based on your age entry. So if you enter your age and you are below 10, you shouldn't be filling the form, right? Now, the next requirement is that values between 10 to 21. So that means if you're between the age of 10 to 21 years old, you are allowed to fill the form, right? So in that case, it means that this form is for people within the range of 10 to 20 to 21 years old. Now, the next requirement here says values greater than or equal to 22 are rejected. So it means that if you're from 22 years old and above, you are not also allowed to fill this form, right? So yeah, we want to test this field. We want to ensure that somebody who is not up to 10 years old doesn't fill the form and submit. And we also want to make sure that someone who is above 22 years or 22 years old cannot also fill this form and submit it. Now, how do we test this, or how do we come up with the maximum test coverage for this particular field with at least minimal or without wasting so much time and writing redundant tests? Now, using equivalent partitioning. So let's use equivalent partitioning to like see how many number of test cases we can actually use to test this particular scenario and be sure or be confident enough to say that, okay, this particular app, at least to a certain level, that this particular app is good to go, or this particular form or whatever, or the field is good to go, right? And so based on the instructions or the steps that I mentioned before, the first thing is for us to identify our input data or our input conditions. And that's what we just did, which is people less than 10 years old cannot fill the form. People between 10 and 21 years can fill the form. And then people between 20 and above cannot fill the form. right? Now, going by this, we have three partitions, right? And you can see here that I have partition 1, values between 0 to 9. So let's say someone who is 1 month old, 2 months old, whatever. But I mean, the person is below 1, so they are 0 to 9 years old. That's partition 1. Then partition 2, we have people between 10 to 21 years old. And then partition 3, we have people between 21 years and above, right? So we have these three partitions. Now, we need to pick one data or one age range from each of these partitions to test and know the behavior of this particular field, right? The first partition is already part of an invalid case, right? They are not allowed, so it's an invalid case. The second partition is valid. The third partition is invalid. So what happens with equivalent partition is after breaking it down into partitions like this, you pick one data, right? So in partition 1, you can decide to say, okay, I want to use a baby of 6 months old age to test. Or you can say, I want to use 1 year, or maybe 2 or 3 or 8 or 9, right? But you just have to pick one, basically. You cannot say you are confused. Like you have to just pick one. So you can just pick one. And in this case, let's say for me, I would say, okay, I pick 7, right? I'll pick 7 years. So, and then that's 1. So keep it somewhere. All of you, keep it somewhere. We have picked 7 to test for partition 1. Now, going to partition 2, we have people between the age of 10 to 21 years old. So, and we are expected to just pick one based on the equivalence partitioning rule. We have to just pick one from this, partition. So I'll pick one. Let's say I pick 11 years. And then from partition 3, you're also expected to pick one, right? So for me, I'll pick 22 or maybe something else, right? Just pick one number, basically. Now, what it means is that you now have 3 datas or 3 values to now test for this particular field. It means that you're going to be writing 3 test cases for this field, or 3 test cases, basically. So you're going to be testing for a scenario whereby the user comes in and tries to fill the form, and the person is 7 years old. 7 was what we picked for the first partition, and the person is 7 years old. Now, you will now watch the application and see how they react to this person that is 7 years old, right? So however the person reacts is what you use to say, okay, partition 1 has failed, or partition 1 passed the test, or it is working fine, or the application is handling these scenarios, or whatever scenarios that fall under partition 1 is handling it properly. Then partition 2, we have picked age 11, right? We also write a test case to actually test for a situation whereby someone who is 11 years old fills this form, or maybe 10 years, whatever it is. But in this case, we've picked 11. The same thing goes for partition 3. So it means that using equivalence partitioning, we are able to get 3 test cases to give us that would actually test for both valid and invalid cases for this particular field, right? I don't know if this is clear. Please, if you have questions, so ask me, or maybe, I don't know, Faith, maybe they'll drop the questions when I'm done. I don't know how.
Yeah, I think that's
do
better.
it. Okay.
Let's just
So please, if you have any questions, or if you're not very clear on any of the explanation I'm giving, please just let us know. So yeah, that is equivalent partitioning for you, right? So with equivalence partitioning, we have like 3 test cases for this particular field, right? Now, the next one we have is boundary value analysis, for short, BVA, right? And it's also another black box test technique, which focuses on testing the boundaries of your partitions, right? Yeah, so the aim is you test around the boundaries of your conditions, um or your input data, right? And the essence of this boundary value analysis, or the aim, or it aims at identifying errors, problems that occur at edge points, right? It's like edge cases. It's used to like help you identify edge cases in some kind of, like, depending on kind of application that you're testing, right? Now, what are the steps that you take to actually achieve this? So the first thing is you identify your boundaries, right? Identify the boundaries of your input conditions or data. Then you now select your test cases based on these boundaries that you've identified. And then you execute your test and then with compare your actual value with your expected result, right? Now, so boundary value analysis is like has two types, or maybe basically divided into two types, right? The first one is the 2-point analysis BVA, and then we have the 3-point analysis BVA. I don't know if this makes sense now, but I know it will make sense in the next slides or in the coming slides, right? So we have the 2-point analysis BVA and the 3-point analysis BVA. All these are actually boundary value analysis, right? But then, yeah, anyway, let's go for that. So I also have a scenario here, which is also the same scenario that I used for the equivalence partition. We're going to be using the same example here, right? But then we are going to be applying the boundary value analysis to come up with our test cases. So for the first case, or for the first solution here, I'm using the 2-point analysis BVA. Now, if you remember what I see, if you see here, you can see that I have like something that is looking like gibberish. A comma A minus B, and then I have B minus plus 1, right? So this is like, you can call it a formula or something, but this is, I use this to help, like, it's let's just call it a formula, right? That you can actually use to get the actual boundaries of what you need, right? So for 2 BVA, I have A, and then I have A minus 1 on the first boundary, or on the first condition point. So A and B is what I use to represent my boundaries, right? My input boundaries, which in this case, in the case of our field, age field, we have 10 and 21. 10 on the lower side, 21 on the higher side, on the upper side, right? So we have two main boundaries from the condition. So A represents 10, B represents 21. So now, going by the formula, we have A, which is 10, and then we have A minus 1. So A minus 1 gives us 9, and that's why you can see 9 here and 10 here. So we are using, for 2-point analysis, we are using just a little bit below our boundary, our lower boundary, right? So just 1 inch below our lower boundary, and then our boundary on the lower side. Then on the higher side, we are having just a bit or a little over or above our boundary on the higher side. And that's why we have 21 and 22, which is B and B plus 1. So B plus 1 is 22 and B is 21. So so going by this, you can see that we have the first part, which is an invalid case, 9. And then in between here, we have 10 and 21, which are all valid cases. And then outside of here, we have 22, which is also an invalid case. So what this means, or using 2-point analysis BVA to test this same age field, it means we would have like 4 test cases, because we're going to be testing with someone who is of age 9, And we're going to be testing with someone who is of age 10, age 21, and 22, right? Which gives us 4 test cases, right? So if you take a look at this and then look at the equivalent partitioning, you see that we have like one more test case to actually test this application, right? Then this is for 2-point analysis. Now we have 3-point analysis BVA using the same example, using the same scenario, right? And then the same formula that I gave before. We have A minus 1. And then in this case, we now have additional A plus 1. And then we have, for the higher side, we have B plus 1, and then we also have an additional B minus 1 for the 3-point BVA, analysis BVA, right? Now, what does that leave us with? Point A represents 10, right? So 10 minus 1 is 9. And then we have 10 plus 1, which is 11, right? And then on the higher side, we also have our point B is 21. 21 plus 1 is 22. And then we have additional 21 minus 1, which is 20. Now, this leaves us with 6 test cases in total, right? And what are they basically testing? They are testing our boundary on the lower side, just a little bit below the boundary, and then just a little bit above the boundary. Now, this 3-point BVA is, I won't say, okay, the 3-point is better than the 2-point, right? It depends on the scenario or the application that you're testing. It depends on the criticality of the application you're testing. So if you look at the application you're testing and you know that, okay, this application is like your scenario is a very critical scenario, and you need more, you need to like double check that your application works well. It won't break at a particular point, because the truth is, 10 and 21, they are all valid values. So you might tend to say, okay, since 10 pass and 21 pass, then these ones can pass. But in some cases, that might not be the case. It might break at 20, it might break at 11, so depending on the criticality of the application that you're testing, you can decide to go with the 3-point analysis BVA. It doesn't also mean that your 2-point analysis BVA will not find you, will not give you the results that you require. But just to double check and to be more confident in the application that you're giving out or that you're delivering, you can decide to say, okay, let's go with the 3-point analysis BVA. Right. So with these 3 points, we have 6 test cases. With 2-point value analysis, we have 4 test cases. Right. So yeah, that's about boundary value analysis. Then the next technique that we have here, which is also the last technique I'll be talking about, is the decision table technique, which is also known as the cause effect table, right? Now, what is this technique? It's also another black box test technique. So basically, all of them are black box test techniques. But this one is usually represented in a tabular form, right? With your input conditions and the corresponding actions or the corresponding results of what, depending on the conditions, right? Now, this is usually used when you have multiple combinations of conditions, and you are also expecting multiple combinations of output. Like there are multiple scenarios, or you have multiple conditions, and then you're also expecting different kinds of actions based on the condition, right? And it's usually used to capture complex business rules, right? So there are some applications that you'll be testing, or functions, or features that you'll be testing, and you can see that, okay, this particular feature has complex rules or complex conditions, right? This would be a very good technique that will help you to like have maximum test coverage, right? With at least the barest minimum. So we have some components of the decision table, and the first one is the conditions, which are the input values that you want to evaluate. Then the actions, which are the behaviors or the output or the result based on your conditions. Then the last one is the rules, right? So in your table or in your decision table yeah, we have different rows, right? And each of these not rows, sorry, columns, right, represents a particular rule, right? Now, there's a formula that I use, which is, you might find it out there. Well, I mean, personally, I use it. Um, 2 raised to power n, whereby n is the number of your condition. So if your conditions are 2, you know that your math will be 2 raised to power 2, which is 4. So it means that your table will have like 4 columns at least for your rules. So you have like 4 rules basically. Now let's see example, or let's see this in play as well. So I have a scenario, an example of so take an example of transferring money online to an account which is already added and approved, right? The conditions for a transfer to happen are account already approved, OTP, match, and then sufficient balance in the account. If all these conditions are met, the money is transferred. If there are not sufficient fund, then an insufficient funds error message is returned. And when OTP doesn't match, then there's an error. Or when there's when transaction is suspicious, then the transfer is blocked, right? So now let's take, for instance, all of us here have bank accounts, right? So I'll just maybe take our bank account for an example. So let's assume that this, what we are talking about here, is our one of our maybe mobile banking application, right? And we want to test the transfer feature. Yeah. Now we have conditions here. You already, first of all, the account should already be approved. So, I mean, you and I know that you can't transfer money from a bank app if you don't have an account, right? Or if you've opened an account but it is not yet approved, right? So you can't really do some things. Now, there's also a condition that says account is already approved, right? So your account should actually already be approved, but it's a condition. Then for the transfer to go, or for you to be able to do a transfer to some money to someone. And then the next rule is that, or the next condition, sorry, is that there should be a one-time password, and the one-time password should actually match what they are expecting, right? Now, and then the third rule condition is there should be sufficient fund in your account. So you should have a sufficient account balance. So we have like 3 conditions. Now, corresponding to these conditions, we also have different outcomes, right? So we have varieties of outcomes based on these different conditions as well. So our outcome is, if the conditions are met, if all the conditions are met, then you can transfer the money. That's the first outcome. Then the second one is, if there is no sufficient fund, right? We now display an error message, which is number 2. And then if your OTP is invalid or doesn't match, you also have an error for that. And then there is also a case where your transaction is suspicious, the account can be blocked, right? So now we want to test this particular app. or this particular feature, transfer feature, and we want to ensure that we have maximum test coverage. So we're going to be using the decision table technique basically. How did I come up with this table that you're seeing on my screen? Like I said on the previous slide, there's a formula 2 raised to power n, whereby n is the number of conditions that you're given. And seeing from what we have read here, we have 3 conditions that we are given. Already approved account, OTP match, and sufficient balance, sufficient account balance, which is 3. So what we have is, so going by this formula, we have 2 raised to power 3, which will give us 8, if I'm not mistaken. 8. So that 8, that is how I came up with this 1, 2, 3, 4, 5, 6, 7, 8 columns that you can see here. And they are the rules, right? They are the rules, which I also call the like test cases now. And then down here, you can see the conditions, right? We have conditions. We have 3 conditions as well. The first condition is we have conditions basically, which is 3. We already identified them. That's already approved account. That is what I name here as AAA. So when you see AAA, you know that I'm referring to accounts already approved. And then the next one is OTP match. Then the SF is sufficient fund. So when you see that, just know that I'm talking about sufficient fund, right? So now, the next, I know that the next question will be, okay, how did you like come up with this TF? What does that even mean, right? So the TF here you're seeing is that the T stands for true, and the F stands for false, right? Which is like a Boolean, true and false. Now, what does this mean? It means that these conditions that we have can either be true or false. It means that an account can, like the account can be already approved or not. There could be an OTP or not. Account could have a sufficient fund or not, right? So it is either true or false. So that's the first one. Then the other question or the other confusion might be, okay, so how were you able to like arrange them in these columns, right? So for some people, they might start by, okay, they might, start by accounts already approved, true, OTP, true, or maybe false. They will write false here, and then sufficient fund, they might say, okay, true or false. So yeah, and then they will keep going like that, like that, like that till they fill up these columns, right? But for me, using the example of what I do and how I make sure that I am able to cover what I need to cover, right? Using this table without making mistake. Because going that way, I might, at a point you might forget which one you have actually given true or false at any point in time, right? So what I do personally is, since I have 8 columns, I first of all divide the 8 columns into 2. I have 4, and then I have another 4. So the first 4, I fill it up with true, right? Which is the first 4, there's possibility of all these being true, like this particular account being true. And then the second column, I also fill it up with false, 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 right? Because I have two possible outcomes, true or false, right? Now, on the next column, I go further to divide my 2 into, like, break it down again. So I fill up with true, true, false, false, true, true, false, false. And then the last column will have like true, false, true, false, true, false. So I intercept it like that. That way, I am sure that each of these conditions gets the exact amount of combinations of true and false. you can count it. Now, let's proceed with okay, finding out what now actually happens, or like how do we now say, okay, this is a test case for us to test, right? Based on these rules. So the first condition says account should already be approved, right? And looking at our first rule, in this case, this is true, the account is approved. Let's say I'm using, in fact, let me say my account, Mary's account, right? So in the first case, Mary's account is approved. The OTP she provides also match, and then she also has sufficient fund, right? So this is the first rule now, or and then this is the first test case, right? So with that, we can actually go ahead and do transfer, or Mary can actually go ahead and complete her transfer, right? Which is the output or the expected result, or the result, yeah, expected result. Now we're not talking about actual result because you're not doing the actual test, right? So transfer, it means transfer. Then we have rule number 2, or test case number 2, where a situation whereby Taiwo has an account and the account is approved. He also provides an OTP which match, but he doesn't have sufficient fund, right? Now, in this situation, we're told that based on the um, requirement here, we're told that in this scenario, we should return an insufficient fund error. The IF stands for insufficient fund, right? I am abbreviating these things because of space, yeah, so that you don't get confused. So we expect an insufficient fund error, right, for Taiwo. Now, the third case, or the third scenario, is Amaka. Now, Amaka has an account that is approved, but the OTP she provides does not match. And then she also has sufficient fund. Now, in this case, we are told to return an OTP error. So it means that the OTP does not match, right? We expect an error for an OTP not matching, right? This is test case number 3. Then the fourth one is Faith. Faith has an account and it's actually approved, right? And then her OTP doesn't match with what she provided. And she also doesn't have sufficient fund, right? So we were told to actually block an account that, returns suspicious. So this could be suspicious. You don't have fund, you want to transfer. What do you want to transfer? Right? So we are expecting we're expecting the account to be blocked, right? Now, that's the fourth test case. And then the fifth one is a situation whereby Taiwo now, I don't know, somebody now says they have an account, but the account is not approved. He's saying that he has an OTP that matches and then sufficient fund. So is that even possible? I don't know. Like, it's not even possible actually, because the account is not approved. It could be that you don't even have an account, or the account they've not finished opening the account. So how do you want to now, so this is not possible, basically. And that's what I mean by MP that I'm putting here. So this is not possible. This is like an invalid case. It's not possible. Yeah. But yes, we have to test situations like this, because people cannot just through enter bank app and then they can just start doing things, right? Then the sixth rule has a situation whereby the account is also not approved, has an OTP, does not have sufficient fund. Then, which is also not possible. The other case is account not approved, OTP not there, but he has sufficient fund. I don't know. I wonder where the fund is anyways. Then the last scenario, we have all of them basically are not uh, they are not met, right? Um, they are not met, so we also don't like. There's no actually there should be a an expected result for this because yeah, it is possible that we don't have any of these things. So this is also like a test. So yeah, going by this rule or this technique, we have like 8 test cases, right? 8 test cases to actually testing. These techniques that we've talked about would actually go a long way to help you achieve this, right? So with these techniques that we've talked about, you can actually apply them in your testing to so that you can actually be, confident to say that yes, your application is consistent with the result. equivalence partitioning. Okay. Is there a relationship? There might be, right? Because you have like partitions, right, for equivalence partitioning, which is like our where we have our 9 and 10, and then we have our 20 and 21, which in the band, which looks like kind of looks like a little like the 2-point analysis BVA, right? Although we have like one a little bit above. But so you might say there's a relationship. You can also decide that okay, there's no relationship. But then that does not mean that you cannot apply both of them to test a particular feature or an application. If you feel like equivalence partition is not enough, or you want to also use equivalence partition and still use your boundary value analysis, which actually, if you use boundary value analysis, you will still get those what's it called? Those values that you got from your partitioning. Not really, but yeah. In some cases, you might get the exact same value depending on you're picking for your testing from the equivalent partitioning. So depending on the value you're picking from your equivalent partitioning, you might still not get it when you're using boundary value analysis. So you can use a combination of both of them, or you can use one, depending on what you're testing and depending on how critical it is, actually. I hope I answered your question.
Not really, but in a scenario, in what, sorry, I don't, I mean, sorry, in what scenario
So,
can we put in the equivalent partitioning to test without having to use boundary analysis? Because my own ideology is that without equivalent partitioning, we can have a boundary value. So, in
without
what scenario,
equivalent partition,
without equivalent partitioning? I believe we have to
yeah,
equivalent partition first before we then select the boundary value of each of these. What we've equivalent. I mean, what we've split the.
because I have I have a question for you people. So maybe we can actually use this. Um, Actually, this question is for you people. You know what? Let me leave it. So, my answer, what's your name again? Sorry. My answer to that, Kumi, is you can actually have do your boundary value analysis without your equivalent partition. Do you understand? Now, but that does not also mean that you cannot use both of them, or you cannot, work with both of them together. But you can actually work with each of them in isolation. You can do your boundary value analysis without having to like think about your equivalence partition. You can also use equivalence partition to without having to like think about your BVA. I don't know if what I'm saying makes sense.
But in what instance can we or can sorry? Can you give an example of where we can use the equal? I mean, boundary value in isolation. And then another thing I don't understand is in what area do can we use equivalent partitioning when it comes to testing?
In what area?
Yes. How do we make use of the equivalent partitioning? Like we've split the value into invalid value, I mean valid, invalid. On how do we practically, how do we make use of it? I don't
Okay, so let me
understand that.
say, for example, let's use, for example, we have a login form. Yeah, you have a login form and you want to test login, right? You know that for login, you need username and password, or maybe you need what's it called? You need
Phone
your
number.
email or password, right? Is somebody saying something?
Yeah, I said, oh, phone number and password.
Or phone number and password. God bless you. Okay, so now you want to test the login feature, right? You will test your field, the username, whatever it is, be it email or password or phone number, right? You're going to write your test cases for that, or you're going to come up with test cases for that, depending on the condition for that particular field. Now, I also use I'm focusing on the password now because password usually have conditions, a lot of conditions actually, right? More than the username. Some username form, some forms or some login and this thing, the username is actually quite a little bit flexible, right? But passwords are really like you have conditions. You can come up and somebody would say, I like some login and this thing, some requirements for the password will be like, will look like, okay, your password should be nothing less than 8 characters, or your password should involve special characters, what's it called? Um Numbers or whatever. But some password
Numeric.
alphanumeric alphabet, and you know a lot of depending on the requirements for that particular field. So there are different password fields, and then there are also some that will just tell you, okay, it shouldn't be less than this, right? So for in a situation whereby you have a password field now, a login form, and then there's the password that says your password should not be less than 8 characters, or let's say should not be less than 10 characters, for example, right? So first, that's a good example where you can actually use your um your what's it called, your um your equivalent partition. Do you understand? You can also decide to use your boundary value in that situation. Now, there's also a situation whereby, okay, the password should not be less than 8 characters, or the password should be between 8 characters or 10 characters to, let's say, maybe 20 characters or 15 characters. If you have a situation like this, you can use equivalent partition. You might not need to employ boundary value analysis. But because this is a login form, and this is a login, and in some cases, it is actually critical to test your login properly so that not everybody can just come and log in with any password. You can decide to use BVA because you want to have, okay, more coverage, more test coverage. Do you understand? So, and then, I mean, yeah, I'm just trying to see if I can think of more scenarios, but like, there are so many scenarios that you can actually use these things. You can use them in combination. You can use them in isolation. Now, like I said before, depending on the criticality of what you're testing. I don't know if I've answered your question, Kumi.
Yeah, thank you.
Any other question? Okay. So I have my own question. Yeah, so please look at what we have on the screen and tell me, like using using equivalent partition, what do you think would be the answer for this particular question? I hope we are still together.
Yes, we are, but it's quiet.
Sorry?
Uh, uh, uh,
Are we thinking about the question, or are we? I need to know. Faith, are you here? Your people are not answering. No.
I believe it requires some little reasoning and time to calculate and then come up with something.
Okay.
Maybe we do the better.
I can
Mm. Okay, Johnny Doe says A. Any other person?
I will be choosing
Sorry?
D.
D. Okay. You have D. Okay. Kumi, your hand is up.
Sorry, I said D. Sorry, that was a mistake.
D. Abi B. Which one?
D.
D.
Yeah, right.
Okay, we have another D. So why do you, the person that said A, why is your answer A? Why is your answer A? Are we still together? Who? Joan, you are not saying anything.
I'm here. Sorry. I didn't say A, I changed it to B.
Okay, okay, sorry, B. Okay, so why is your answer B?
Oh, it's still very confusing, but I think for me it's because they don't meet the requirement. That's what I thought about.
Okay.
Yeah, they don't meet the requirement of the three.
Okay. The person that says D, why is your answer D?
All right. So this is the way I understand it. The first condition statement, we have 4,000 pounds a year for salary tax rate. So you can pick any value less than 4,000 to 4,000 mark.
Sorry, I don't know. It's as if
Can
I'm
you hear
not
me?
hearing you clearly. Yeah, I can hear you now. Please go ahead. Thank you.
Okay. So for salaries lesser than 4,000 to 4,000 is one equivalent partition. So the next bullet point says anything above 4,000, that's adding plus 1,500 is taxed at
Mm-hmm.
10%. So that's another equivalent, that's another partition. So that would be like 4,001 to say 5,500. That's within. So that's where we have it as 4,200. Any value within 4,200 is within that uh, partition. Then the next
Mm-hmm.
one now says above that 28,000 pounds. So going by that, anything above 5,500 enters into that next partition, which is 5,006. So that's why I put it there. Uh-huh.
Okay, so the question says, sorry, who also answered again? The person that said C. Damilola, what's your reason for saying C? Is Damilola still here? Okay, let's just round off. Yeah. Um, your um, your answer is correct. Um, um, sorry, no.
More.
Said B. Did you say B? Hold on. Let me check.
D.
No, I said
D.
I was the one that just gave the explanation now for D. Why I take 4,000.
B. For
D.
B, right? For D. D.
Yeah.
Yes. So yes, you're correct. Yes, please. You're correct. You're right. I thought it was B. You're
No,
correct.
D.
Yes, she's actually correct because the question says to the nearest whole pound, which of these groups of numbers fall into three different equivalent classes, right? And each of these three that she has mentioned, which is the D, has actually like fall into different equivalent classes. So for this question, we have like four different equivalent classes, and these option D actually fall within each of those classes. Yeah. So congratulations,
And
Imo Darak. Yes.
it's fine.
And for answering the question correctly, you have 1,000 naira airtime from me. So reach out to
Yeah.
Faith and I'll give you. Okay. Yeah, that will be all from me. Thank you for joining the class and for listening to me. Faith, done. Sorry.